Hello, everyone. Mr. Minix, my name, math is my game, and my Algebra 2 classes are about to take their Chapter 2, Section 1 quiz on tomorrow. And there's some additional material that I think they need to see. My one class might have talked about some of this stuff, but the other ones have not. So we'll just go ahead and start with domain and range. Domain and range. Now we know that domain and range refers to the x values. We know that domain and range refers to all the x values for a particular relation. But what ends up happening with domain and range is something weird. If we had a relation that looked like this, whoop, whoop, whoop. So let's see, we got the point P, which looks like it goes through 1, 2. And we got the point Q, which looks like it goes through the point 4, 3. And we got the point R, which goes through the point 6, 5. R goes through the point 6, 5. And those are the only points in our relation. Well, we could say that our domain is 1, 4, and 6. And we could say our range is 2, 3, and 5. And the world would be a nice, happy place. And everybody would get that right. Well, what we need to talk about is what happens with the domain and the range if our graph isn't just comprised of points. What happens with the domain and the range if our graph isn't merely comprised of points? What happens with the domain and the range if our graph does something like this? Woo! So this end point is still the point 1, 2, and this end point is the point 6, 5. But what's happening is this relation goes through all the points in between those. So what I'm trying to tell you is if we think about the domain, 1 would be in the domain, 1 would be in the domain, and 6, of course, would be in the domain, but also 1.000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000001 would be in the domain. 0.00000000000 would be in the domain. And also in the domain would be 1.0000000000000. Somebody can say stop anytime. 0.0000000. All those are going to be in the domain. Are we going to have time to write that? No. And that's why we have something called interval notation. That's why we have this thing called interval notation. My one class saw this already. I didn't mention it to all. So interval notation, what interval notation means is that we're going to write the small number on the left. We're going to write the small number on the left. We're going to write the large number on the right. And we're going to put a comma in the middle, a comma in the middle, a comma in the middle. So if we look at our domain, it goes from 1 to 6. So the way we would write that then would be from 1 to 6. And then over here on the sides, we need to have some kind of symbol to close those in. And you might think to put parentheses. Well, in this particular instance, we're not going to put parentheses. Because the point 1 is actually included, because the point 6 is actually included, what we're going to do is we're going to put brackets. We're going to put brackets on the end of that. So what that expression says, bracket 1, comma 6 end bracket, what that says is the domain has a minimum value of 1, which is included, and a maximum value of 6, which is included, and the domain includes everything in between those. I know it doesn't look like it says that much, but that's what it says. Bracket 1, comma 6 end bracket means the domain is comprised of the number 1, 1.0000, and you get the idea. Everything in between 1 and 6. Okay. So similarly with the range then, we could say that the range goes from what to what? From 2 to 5. And again, we would put brackets on the end of that. Later on this year, we'll concern ourselves with when we put something other than brackets. I'll just mention it briefly. If there were an open circle, we'd use parentheses. If there were an open circle, we'd use parentheses, but when we want to include it, we use brackets. So the range goes from a minimum value of 2 to a maximum value of 5. There is another way that we could write that. Since this is our x-axis, we could say We could say that the domain, an equivalent way of writing this is to say that the domain is from 1 is less than or equal to x is less than or equal to 6. What I'm trying to say here is that this expression and this expression mean the exact same thing. It's another way to write it. That's called inequality notation. That's called inequality notation. And one of the multiple choice questions on tomorrow's test is going to use that. So the range then, because this is the y-axis, the range could be thought of as y is between 2 and 5. Okay. So domain and range, if we have some kind of graph where it's continuous, where it's not just individual points, we need to use either the inequality notation or the interval notation. Okay? All right. How do we feel about that, okay? So basically what's going to happen, there's going to be 1 or 2 multiple choice questions like that, and then another couple where you're going to have to figure things out and write things in. Okay. Okay, the next item up for bids we need to talk about is graphing lines. Graph lines. The good news is on tomorrow's quiz, these are all multiple choice. The good news is on tomorrow's quiz, everything's given to you in slope-intercept form. Remember y equals mx plus b? They're going to tell you something like this. They're going to say, okay, hotshot, f of x equals negative 1/5 x. I said negative 1/5 x plus 2. And they're going to give you 4 graphs, and you're going to have to pick the right one. And it should be really easy. They're going to give you one that looks like this. They're going to give you one that looks like this. They're going to give you one that looks like this. And they're going to give you one that looks like this. Let's think about this for a minute. The slope is that number in front of x. That slope, the slope is negative 1/5, which is negative. What's that mean the line's going to do? It's going to go down, or the line's going to fall from left to right, right? So which graphs is not going to be the answer? Yeah, it's not going to be this one. And it's not going to be this one. And it's not going to be the bottom right one either. Why not that one? Oh, our y-intercept. Yeah, our y-intercept. Our y-intercept is that other number. Our y-intercept's 2. And this graph down here doesn't have a y-intercept to do. It's got a y-intercept. If you can figure that out, the graphs are going to be easy. You probably won't even need to touch the graphing calculator. Make sense? Okay. Speaking of the graphing calculator, if you need to enter a fraction on there, hit the divide button first on the TI Inspire. Hit the divide button, or there's a fraction template. You'll figure that out. Okay. The last thing we need to talk about then is whether or not something is linear. Whether or not something is linear. They're going to show you something like this. They're going to say f of x is 2 plus 5x. They're going to say g of x is x squared plus 1. They're going to say h of x is 4 times the absolute value of 3x. And they're going to ask you, are each of those linear? Are each one of those linear? Real easy to figure out. All you got to do is graph them. You could use a graphing calculator to graph them. So if we look at this f of x, that's 2x plus 5. Dude, isn't that, I'm sorry, it's 2 plus 5x. That's 2 plus 5x. 2 plus 5x. Isn't that basically almost slope-intercept form? It's like 5x plus 2, right? 5x plus 2, so it's going to do something like this. It's going to go something like this. Whoop! Is that linear? Does it look like a line? It is. All right, what about this next one, x squared plus 1? When you graph that, you probably don't know what its graph's going to look like, and that's okay. You could use the calculator to graph it, and when it does, the calculator is going to say, okay, hotshot, this one looks like this. Whoop! Is that linear? No, it's not. No, it's not. And then this last one here, h of x is 4 times the absolute value of 3x. When you graph that, it's going to look like this. Whoop! Whoop! Is that linear? Not exactly. So for something to be linear, there's one little thing we're looking for. We're looking at this exponent up here on x. If the biggest exponent on x is a 1, like it is in this case, like it is in this case. And I know what you're thinking. You're thinking, well, what about this bottom one? It has an exponent of 1 also. Yeah, it does, but it's got the absolute value attached to it. Absolute value functions are not exactly linear. So the answer to that one's no. This one's a yes, okay? So again, you could just graph them. If it looks like a line, it's linear. If it doesn't look like a line, it's not linear. What if it looks like a squiggly line when you graph it? What if it does something like this when you graph it? Is that linear? No. Questions? Comments? Well, that's it. I hope everybody does a great job on tomorrow's quiz. There's 20 questions. I'm probably going to take it out of maybe 85 or 90 again. Have a terrific day. Shout out to my second period class for being so awesome. And a shout out to Mike Jones.